Good afternoon, everyone, and welcome back to Lecture 8 of Thermo Shorts, where we'll try to distill down the big ideas that we've been doing in our hour-long lectures. So in this class, we just have a large example where we're fixing a whole bunch of states. So we have a system that's filled with water, and we'll try to figure out if that's liquid water, if it's superheated water vapor, or if it's some combination of saturated liquid and saturated water vapor. So how do we do that? In order to fix a state, we know that we need two independent intensive properties. And in the handout that we get in this class, we're given a whole lot of information about 6 different states. And we're asked to fix these states. So not only do we have to find the numerical values, but we're asked to plot these states on PV and TV diagrams. So these diagrams here are to scale, but it's okay if you're just drawing sketches. So here on a PV diagram, we have our vapor dome. We have our saturated liquid line, showed here in blue, that's quality of equal to 0, and a saturated vapor line, where quality is equal to 1, that's red. Now, this is a PV diagram, but it's possible to draw constant temperature lines on these graphs as well. And a constant temperature line on a PV diagram starts high and moves down and to the right as the specific volume increases. Now, that's not true under the vapor dome, because under the vapor dome we have a flat line because pressure and temperature are dependent under the vapor dome. Now, if this temperature was higher, we would shift this line upwards. And if it was lower, we would shift the line downwards. If we're drawing a TV diagram, this is almost the same, except now if we're drawing a constant pressure line, it moves up and to the right, still being flat under the vapor dome. But still, if our pressure moves up, we slide this line up. And if our pressure moves down, we slide this line down. So now what I've done is I've taken all the given information from the problem and put it on this state table. State tables are very important in thermodynamics because they'll help us keep account of all the information we're supposed to know. Now, when I look at this state table, I feel pretty confident that I can fix all of these states, or at least I'm hopeful, because I know 2 pieces of information for all of these states. Now, there is one case over here in state 1 where I know the temperature and the pressure, and another over here in state 3 where, again, I know the temperature and pressure. So here, I'm hopeful that I can fix those states, but in order for that to be true, I have to show that I'm not under the vapor dome. So how do we get started? Let's start at state 1 because it's the first one on the table. Here, I know that my temperature is 460 degrees and my pressure is 80 bar. So how do I know the phase here? So it turns out the phase in this particular state is up here in superheated vapor. The way that I know that is here I would go to table A3, where I have nice round pressures in the leftmost column, and I would find what the saturation temperature is. So that's what the temperature is where water boils. So the temperature where water boils at 80 bar is less than 460 degrees. That means we're above the boiling temperature, which must mean that we have a superheated vapor, and I can fix this information on state 4. So I won't do the interpolation here. You can check it out in the longer video if you like. But I've put the information from the interpolation into my state table here. Now I move on to state 2. State 2, it's easy to tell where we are because here they tell me the pressure, but they also tell me the quality. It only makes sense to learn the quality if we're under the vapor dome. Quality is only really defined under the vapor dome. So here for state 2, I'm going to look under the vapor dome. I've got to decide whether that's table A2 or A3. And the way I figure that out is I look at the information that I have. So here I know the pressure, and the pressure is a nice round number. So I look to the far left column, and on table A3, I have pressure in the far left column. So that's the table that I'm going to use. Now our next state is state 3. And like state 1, we know the temperature here and we know the pressure. So like state 1, I'm going to go to my pressure table, table A3, and find the saturation temperature for 7 bar. And again, it's below 440 degrees. So here I know that I'm boiling my liquid. So again, it's superheated vapor, and I'll look this up on table A4. State 4 is a little bit like state 2, but here, instead of knowing the pressure, like I did in state 2, I know the temperature. But in both cases, they give me the quality, and that tells me for sure that I have to be under the vapor dome. So in this case, I'm going to look on table A2 instead of A3 because I have a nice round temperature. So A2 is the easiest table to look this up on. State 5 is a bit of a special case. So now they tell me the temperature, but they tell me the quality is 0. So I could look this up on maybe state 5 because this is a liquid, but because it's a saturated liquid, I'm going to look this up on my two-phase tables. I'll use table A2 because again, I know the temperature. And the nice thing here is when I'm looking for the specific volume or the specific internal energy or the specific enthalpy, all of these values on the table will be subscript F. So it'll be VF or HF or UF because this is the saturated liquid. Now finally, I'm told for state 6 that I have a pressure of 80 bar and a specific enthalpy of 181.94. Now we don't exactly know what enthalpy is yet, but that's okay. We'll deal with that a little bit more. For now, it's just an intensive property I can find on the table. So how do I know where I should look in this case? Right? So we have pressure and we have specific enthalpy. How do we fix the state? So when I'm not sure, I'm going to look on the two-phase table. So in this case, I look at table A3 because I know the pressure. Now on A3, it will tell me HF and HG. That's the specific enthalpy associated with the saturated liquid and the saturated vapor. Now, if the H value that I know for state 6 is in between HF and HG, then I'm under the vapor dome. I have some combination of saturated liquid and saturated vapor. If H6 is greater than Hg, that means we have a superheated vapor. And if H6 is less than HF, that means that we have a subcooled or compressed liquid. And that's what happens in this state. So if I look up HF here, it's bigger than 181.94 kilojoules per kilogram. So in this case, I know that I have a subcooled liquid, and if I want to use the tables to fix this state, then I've got to look on table A5 and do some double interpolation. So in this problem, I didn't show you any of the interpolation steps. If you want to see those, you got to go to the long version of this lecture, but you can always try to do these by yourself for a little bit of review. But if you want the answers, they're all here in my table. So thanks for joining me on Thermo Shorts. I'll see you again next time.
I'm here. Dad, I'm here.
How are you?
Can you read it to me?
Okay, we'll read it to you. Just let me pause.